Okay, in this video I'll show you how to find the equation of a tangent line. And the three main steps we need to remember when we're doing this is, number one, we're going to differentiate the original function. Okay, and hopefully we already know how to do that. If not, there's another video, or you can use your notes. Next thing we're going to do is we're going to substitute one of the x-coordinates, well, the x-coordinate, into the derived function to find the gradient. And after we find the gradient, what we do is we use the point that was given, and we use the gradient that we just found out to write the equation of that tangent line. And the general formula for the equation we're going to use is called a point gradient equation, which is given by this right here. Okay, just a reminder of this. M represents the gradient, which we figured out in the second step, and x1 and y1 are some point on the curve that we were most likely given. Okay, so let's try some examples. Okay, so here's my original function, and I'm going to differentiate it first, differentiate the first one. So we've got dy by dx, or just y dash, equals 2x minus 2. There's the derived function. Next, I just substitute the x-coordinate in for x to find the gradient. So at this point, here's x1, 2 times 1 minus 2. So the gradient at this point gives me, I get a gradient of 0. So let's just recap real quick. So at this point, remember this is x1 and y1. This represents my gradient now. And finally, what I do is use the point gradient equation to write it up. Now, a gradient of 0 means it's going to be a horizontal line. Okay, it's not going to have any positive or negative gradient to it. So y minus 1 means it's going to be y minus a negative 5 means plus 5. My gradient 0, and then x minus 1. And to write it in gradient intercept form, I distribute and then change that over to the other side. And when I distribute this, 0 times anything is 0. So I just get y plus 5 equals 0. Shift the positive 5 over to make it negative 5. And here is my equation for the tangent, which means it's a horizontal line, so it has no gradient. Well, the gradient is 0, I should say. All right, let's look at another example. Okay, let's look at this example. Differentiate it. So f dash x gives me 3x squared minus 4. And substitute the x value, which is negative 3, into the gradient function. So f dash negative 3 equals 3 brackets negative 3. Don't forget to put brackets around that. Squared minus 4. This will give me the gradient at x equals negative 3. And we get a gradient of positive 23, I think. This is 9 times 3 is 27. Take away 4 is 23. Okay? And this notation right here just means that at x equals negative 3, the gradient is 23. Now we write our formula to get the equation of the tangent. So let's do that. Remembering that's x1, that's y1, that's m for gradient. And we do y minus y1. And if y is negative, it turns to plus. Y plus 15 equals my gradient, which is 23. X minus x1. And minus a negative 3 is a plus 3. Okay, that's the correct equation. And if you want it so you know the y-intercept, you distribute, and then minus 15 from the other side. So that gives me y plus 15 equals 23x plus 69. Subtracting 15 gives me y equals 23x plus 54. Now, what if they give me the original function and just the x value, and they don't really give me a point, but they just say, here's an equation, what's going to be the equation of the tangent line when x equals whatever. So let's look at an example like that. Okay, like this example right here. Here's the equation. What's the equation of the tangent line when x equals 4? First of all, remember what I need. I need the gradient, and I need x1, y1. So to find the y-coordinate, I do need to take x equals 4 and substitute it into the original equation to find the y-coordinate. I haven't done any calculus yet. I haven't differentiated it yet. So this is just the algebra substitution to find the y-coordinate, which I think it gives me 12. 16 times 3 is 48 minus 36. Okay, so what does this mean? It means that that's my coordinate right there, which I'll need. When x equals 4, y equals 12. That's x1, that's y1. We will use that later on. Now we differentiate it to find the gradient function. And that's g dash x equals 6x minus 9. Substitute my x value. What's my x value? 4. 4, got it right there. So g dash 4 equals, at x equals 4, gradient's 15. So that means m equals 15 at this point. So I've got everything I need to solve here, everything to write the equation. Okay, so general formula, y minus y1 equals gradient x minus x1. Substitute what you have so far. That's after I substitute x1, y1 and the gradient, distribute, and then add 12 to the other side. And you're in business. Okay, and my final equation, y equals 15x minus 48. 15 is a gradient, that doesn't change. Negative 48 is the y-intercept of the tangent line. And that's just how I do some examples. There's lots more, but this should start you off. Okay, good luck. Okay, quick bonus question here. Find the equation of the tangent line to this function, this curve, at the point where the gradient is 4. So I don't give you the point on the curve, I give you the gradient. See if we can get this one. Remember what I need for the equation of the tangent line? I need a coordinate, xy, and I need a gradient. So my first step here is going to be to differentiate this one and set it equal to 4. Because when I differentiate that, that's the gradient function, and the gradient is 4. So f dash x equals 4x minus 8, and the gradient is 4, so I set this equal to 4 and solve for x. That's where I got that. When I solve for x, add 8 to that side, I get 12 equals 4x, so x equals 3. Okay, getting there. Now I need the y-coordinate. I've got the x-coordinate, now I need the y-coordinate, so I substitute that x into the original equation to find the y-coordinate. And after I substitute that 3 in here, I think I get a negative 6 for my y-coordinate. So that means x is 3, y is negative 6. And now I have everything I need for my equation. Here's my point. Here's my gradient. Let's do it. Okay, and so here's our final equation. Substituted the values in here, expanded the brackets, moved that negative 6 to the other side, and I'm finished. Good luck. Over and out.